And it's time for questions. Kennedy, would you please show previous slide with your main result? So I'll just start. So when you go from lower right to upper left, you get more and more negative electric field, and the rate increases. So the rate is the amount of charge transferred through the interface. How does this result agrees or contradicts with Ohm's law, on your opinion? And you can repeat what is Ohm's law just in case that we all are on the same page.
I think it matches Ohm's law pretty well, right?
To me, yes. There is some correspondence, yeah, which is good. Okay, so let's check other questions online or in class. So there is a question from Professor Hilina about the way to compute reaction. Like you did use slope, but
well, the question was in the beginning when she was introducing her method, she called in a term which was e to the power minus kt, I guess. If you go to this slide with your formulas where you're calculating the probabilities. Yes, next.
This one?
Well, this and maybe next. No, previous one, yeah. Previous one, please. Okay, yeah. So you call this k as a you probably just, it was an error, just you thought about one thing and you call it differently. You call it reaction constant or reaction rate, reaction constant, something like this. Can you explain once more what exactly is this k? What's the meaning of this k?
The k is the reaction rate constant.
But what is the reaction you have? You have electron in the field, in the electric field. What kind of reaction you are talking about?
What is changing in your system? What is transferring?
The electrons.
Okay. So you are using the word reaction rate as a synonym, as a replacement of what?
The electron transfer rate?
Yep.
Okay. So it's because there's no really reactions there, right? So reaction rate or reaction constant sounds a little bit awkward. So you just talk about the rate for the electron transferring from one side to another side, or if you have the interface between two different materials from one material to another through the interface, and so on. And can you explain when you're talking about positive field, negative field? What do you mean by this? So what does it mean when the field is positive? What exactly it means for the electron?
That there's a higher rate.
Can you explain it from just interpretation in physical terms? What does it mean? Why is it going with a higher rate? Can you interpret your results? Why when you have negative field, it has 0 for the rate at all, because it's kind of in the same place, right? And when positive field, then you have this rate transfer from one side to another side.
I would just answer yes.
No, answer yes doesn't work, because I was asking you for physical interpretation. What does it mean? Or what is exactly the physical meaning of these results? Why? You cannot say yes for the question why. Why when you have positive field, your rate is big, and when you have negative field, your rate is almost 0?
Well, I think because the positive values that created a more change in the slope which would result in a higher electron transfer rate. Whereas the
Go to the very first slide.
Go to the slide where you show your potentials. Yes, one of those green lines. Before?
What one?
Yeah, one of those. So, do you have equivalent semiconductors on the left and the right from the midpoint?
Yes.
Yes or no? Are they same or different? Like before 40 and after 40, what is different?
Between the green lines?
Yes, in green lines. Where the atomic attraction potentials are deeper, on the left or on the right?
On the right.
So your material to the left and right from the interface are not equivalent. And to which direction electron will be more happy to go? To lower potential or to higher potential?
Lower potential.
Mm-hmm.
Lower potential.
Okay, so it is more energetically favorable to go from the left to the right, even in the absence of the field.
What was the question?
It's not a question, it's a statement that you can answer yes or no. It is more energetically favorable for electron to go from the left to the right, even in the absence of the field.
Yes.
Yeah.
Independent, what is your left, what is your right? So you're saying that your electrons will move without any fields, and why? What's the reason to imply the field?
Svetlana, you're killing me.
Excuse me completely. I don't understand what's going on in this discussion at all. I thought that your positive negative means also the direction of your field, right?
Yeah.
Yes, she did.
And of course, electron doesn't want to go to the negative contact. They repulse from negative, and they will attract it to the positive charge. So this really depends on whether you get potential being positive or negative, right? So the direction.
Right.
Okay, I'm done with my question.
Okay, so Kennedy, there is a natural potential driving electron from donor to acceptor, but your electric field can speed it up or slow it down, right?
Right.
Okay, I think the question is answered. Are there more questions to Kennedy in class or online? So if no, please join me in thanking Kennedy for presentation and answering questions. And the